Okay, we're going to talk about IV graphs, or what we call current voltage characteristic graphs. And what these graphs essentially do, if you have an electrical component, it describes what the current through this component will be if you apply a certain potential difference across it. So for example, if you apply certain V over here, this graph will tell you how much I it will draw. And how you do that, simply read off the graph. So if I apply, this amount of potential difference, go here, and that's the amount of current you will draw. So also from the IV graphs, you will be able to tell how the resistance of a component changes as the potential difference changes. Simply, of course, take this value of V divided by this value of I, and you will get the resistance. And so graphically, the way to do that, okay, we know that the resistance will simply be the inverse gradient of the straight line from the origin to the point of interest. Okay, so you're going to take the inverse gradient of that. And a common mistake some people will do, they will take the inverse gradient of the tangent. That's not what you should do, because R does not equal to dV di. R is always an average value. Okay, so this is wrong. Okay, you should take the inverse gradient of this line and not this line. So moving on, we are going to look at the IV graphs of certain types of electrical components. And first, let's introduce Ohm's law. Right? Ohm's law states that the current through a device is directly proportional to the potential difference across it if the temperature remains constant. Well, in other words, we're saying something like this. We all know that V equals to IR, and so I, of course, equals to 1 over R times V. Okay, and that's why I is directly proportional to V. And so this is actually implying that if the temperature remains constant, your resistance remains constant. Well, this doesn't actually happen all the time in real life, but typically in the A levels, ohmic devices will be your fixed resistors, like so. Okay, and the IV graph of an ohmic device will always be a straight line through the origin, like so. Okay, you can even extend to the negative side. Okay, and understandably, when your IV graph looks like this, your resistance is always constant, right? Because if I take any value of V or I, whatever, you'll notice that the straight gradient, inverse gradient of the straight line from the origin to that point is always going to have the same value.